목소리 안 들려요.
여보세요?
이제 들려요.
아, 이제 들려? 아, 미안해. 나 이거 마이크 뮤트 되어 있어. 오케이. 그래서 1번 5x squared 맞았고 2번 넘어가자. 6y to the fifth, 36 and 48y cubed. 이건 도경이가 해볼래?
저 이거는 지금 4번이죠? 그러니까 number 1, 2, 3,
5번이야.
이거 잠시만요. 번호 좀 다르게 돼. 4번에 뭐지? 왜 이렇게 된 거지? 6 나왔는데.
6? 6 맞았어. 다 6 나왔지? 3번 해보자. 3번은 8z to the fourth and 4z squared and 2z. 이건 예승이가 해보자.
지금 6번이죠.
6번 맞아.
2z 나왔는데요, 전.
2z is correct. Let's move on. Let's go over factoring by a common factor. Our first question is 5x to the fourth minus 125x squared. 설리나 이거 해볼래?
5x squared parentheses x plus 5 parentheses
Plus
and
5 parentheses?
and then x minus 5 parentheses.
Minus 5. Nice. Did everybody else get this?
Yes.
Okay. Let's do the next one. Our next problem is 7y cubed minus 3y plus 5y to the fifth. Back to 예지. 이거 뭐 나왔어?
I'm not sure, but I got y parentheses 7y squared minus 3 plus 5y to the fourth power parentheses.
Plus 5y to the fourth.
저 형.
응?
교전 문제 있잖아요. 5x4
이거.
얘기. 그거 위에 5x4에다가 밑에 5x2 squared 했는데 x square 아니에요? 안?
다시 말해줄 수 있어?
그러니까 5x square 하고 안에 어떻게 된 거지?
안에
지금
그 x squared minus 25를 simplify해서 받은 그거예요.
이게 어떻게 나오냐고? 이거
그러니까
한번 해볼까? 그냥?
저는 이게 x square plus 5가 나왔거든요.
x squared plus 5.
일단 5x square 하고 그러니까 위에 거 더해줘서 2
5x
plus 2 and 5x4 왜 이러지? 뭐지?
5x squared를 일단 여기서 빼보면 여기 x squared가 남고 여기는 negative 5가 남지.
네,
negative
그래서
25. 미안. 네거티브 25가 남지.
네.
이거 말하는 거야? 이건 이걸로 simplified. 이게 이거랑 똑같아. 이걸 또 factor 해야 돼.
아, 그게 U 플러스 V 그건가? 아닌데? 맞나?
이게 special case 기억나? 이게 그 중에 하나지. x squared minus 25. middle term이 없잖아.
아, 영상 보긴 봤는데 저번 주에 안 들어가지고.
그래서 이거 simplify factor 하면 이걸로 나와.
아, 네.
다시 이걸로 해보자. 이거 다 이거 나왔지?
네.
오케이. 그럼 다음 걸로 해보자. 4a cubed plus 14a squared minus 18a to the 7th. 이건 민혁이가 해볼래?
이게 2a
2a
2a 이거 어떻게 했는지 까먹었다.
어떻게 하는지 까먹었어? 답은 나왔어? 답은
네.
안 나왔어?
답은 나왔어요.
답은 나왔어? 답만 알려줄 수 있어?
2a squared
응?
이거 어떻게 읽어? 이 괄호
이거?
이거 parentheses
응.
2a plus 7 minus 9a to the 5 power
응?
parentheses.
맞았어. 다 이거 나왔지?
네.
오케이. 다음 섹션으로 넘어가자. 다음 섹션은 어디 보자. Factoring high degree polynomials. 첫 세 문제만 해보자. Our first one is x cubed plus 7x squared minus 5x minus 35. 이건 치우가 해볼까?
Parentheses, x squared minus 5, and then another parenthesis, x plus 7.
x plus 7. Nice. Did everyone else get this?
Yes.
Yes.
Yes. Okay. Let's do the second question. The second question is 2x to the fourth plus 4x cubed minus 30x squared. 이거는 지원이가 해볼까?
I got 2x squared, parentheses, x minus 3, parentheses,
x minus 3, parentheses.
parentheses, x plus 5, parentheses.
Okay, did everyone else get this?
Yep.
Okay. 하나 남았네. 이건 x squared plus x minus 6 and 2x squared plus 4x. 이건 예승이가 해보자.
네, 잠시만요. 이게 몇 분인지. 네네. 이게 I got x minus 2, parentheses x minus 2, close parentheses, another parenthesis, x plus 3, close parentheses, parentheses 2x,
parentheses 2x,
close parentheses, and then parentheses x plus 2.
parentheses x plus 2. Nice. Everybody else got this, right?
저 도무지 factoring it 파트 너무 이해가 안 가요.
factoring 어느 거?
지금
뭐가 이유?
그것도 그렇고. 그러니까 x
Factoring-
2자 왜 x 2가 되는 거예요?
아, 이게 왜 이게 이걸로 갈라지냐고?
왜냐면은
어.
-6는 -3 multiply 2 돼도 -6이 되잖아요.
이것만 해보자 따로. 이걸 factor 해보면 it's a trinomial, so we factor into two binomials. Our starting term is an x squared, so we multiply two x's. We know that our first two terms are these x's then. To get -6, you can either do 3 times -2, you can do 2 times -3, you can do 6 times -1, or you can do -6 times 1. But we want a positive 1, x. So when we add these together, we want a positive 1 because that's our middle term. Let's start from the bottom. If we add -6 plus 1, we get a -5. 6 plus -1 is 5. 2 plus a -3 is a -1. 3 plus -2 is a positive 1. We want this answer. So we use 3 and -2. We insert 3 and -2. 이거
네.
맞는지 곱해보자. So FOIL, we do out front. X to x is x squared. Outside, x times -2 is -2x. Inside, 3 times x is 3x. And last, which is 3 times -2 is -6. -2 and 3x simplify to x. So this is correct. 어떻게 하는지
이해됐어요.
알겠어?
네.
이해됐어? 다행이다. 그럼 이거 다 나왔지 이거?
네.
Okay. Let's move on with factorization with substitution. This might have been harder because I didn't explain it as much because I was running out of time. Hopefully you guys were able to solve everything though. Let's try the first question. X minus 5 squared plus 2y cubed times x minus 5 again plus y to the 6th power. Where did I leave off? 누가 제일 마지막으로 했지?
제가 방금
예승이가 했어?
네.
예승이 다음에 도경인가? 도경아, 네가 해볼래?
네. 한번 해볼게요. 잘 모르겠는데.
잘 모르겠어. So the first thing we want to find is the structure. Is it u plus v squared? Is it u minus v squared? Or is it u plus v? Or u times u minus v? 이거 셋 중에 어느 거 같아?
u plus v squared.
U plus v? You're right. So to identify the structure, we know it's u plus v squared. What do you think u and v is?
u is x minus 5 squared.
X minus 5 squared? Like that?
I'm not sure.
Not sure. Okay. Let's leave it for now. What do you think v is?
v? Is it u plus v is right?
U plus v? U plus, this is right, yeah. This is the right structure.
I'm not sure whether we use that 2y,
2y.
yeah,
Okay.
that one, or not. So
How we find u and v is, oh no, we look at the end terms, the first and last terms. We just ignore the middle term. We don't really care about this right now.
yeah.
So if you look at this equation, u times u equals u, right?
Yeah.
U times u equals this. So it's something times something equals x minus 5. So u must be just x minus 5. Since x minus 5 times x minus 5 is this, right?
Yep.
What do you think v is then?
Y and y power 3 and yeah, y 3.
Y to the third.
Yeah,
Y to
cube,
the
y
third
cube.
is right. Yeah.
Yeah.
Y cubed times y cubed is y to the 6th. So y cubed is right. Okay, so we identified the structure. We found what u is. We found what v is. And now to factor the expression, we just plug it in this structure. We already know what u and v is. If we plug it in, u is x minus 5, right? So instead of u, we write x minus 5. And v is y cubed. So instead of v, we write y cubed. And we have a squared left. So that's our answer.
Okay.
Get it?
Yeah, I got it.
Yeah, pretty simple, right? Let's try the next one. Next one is 9x squared minus 4y to the 6th. 이건 설린이가 해보자.
Parentheses 3x minus 2y to the third power. Parentheses.
3x minus 2y.
Then parentheses 3x plus 2y cubed. Okay.
So 3x plus 2y cubed.
Cubed.
Okay, nice. So you went straight to the factored expression. To explain what 설린이 did, 9x squared plus minus 4y to the 6th. Our structure here is u plus v and u minus v because we don't have a middle term. So u is going to be 3x. Since 3x times 3x is going to equal 9x squared. V is going to equal 2y cubed, since 2y cubed times 2y cubed is 4y to the 6th. And you just plug in u and v into this equation. So 3x minus 2y cubed and 3x plus 2y cubed. Let's try one more. Actually, let's move on to the next section, which is factoring polynomials with structure. Did we do this? No. Wait. Did you guys do this part? 16x to the 6 minus 81.
Yes.
Oh, you did? Okay, nice. Let's go back to Yeji then.
I got what?
What did you get?
I got parentheses 4x cubed plus 9 parentheses, another parentheses 4x cubed minus 9 parentheses.
Nice. Did everybody else get this? Okay, let's move on. Our next question is 49 squared plus 70 CD minus 25 D squared. 이건 민혁이가 해보자. 민혁아, 이거 했어?
지금 하긴 했는데
음.
지금 다시 해봤거든요. 틀린 것 같아요.
아, 틀린 것 같아?
네.
그럼 틀린 것 같으면 시우가 해볼래?
Parentheses 7c plus 5d and then close squared.
Closed. Squared?
Yes.
7c plus 5d squared. Okay. Did everyone else get this?
Yes, but it's plus 25. Like the answer, like the equation.
Oh,
Plus
is it plus
25.
20?
Yeah.
All right. Oh yeah, I wrote it wrong. Yeah. Okay. Yeah, that makes sense. Okay. And let's do just one more problem. 4w squared minus 25. 민혁아, 이건 맞은 것 같아?
아마도요.
아마도요? 오케이.
일단
해볼래?
해볼게요. Parentheses 2w plus 5 enclose and parentheses 2w minus 5.
Minus 5. That should be correct. Nice. You guys did great on the homework. Let's move on with our lesson for today. So today's lesson is pretty simple. You guys remember how to divide, right? Just dividing. It's what? Elementary math. But we are gonna divide with variables this time. So when we normally divide, for example, there's two examples. 3 divided by 81. Let's do 4 divided by 27. So the first thing we do in this example, it's really simple. We see how many times 3 go into 8, right? How many times did 3 go into 8? It goes in twice. And we just put 2 times, leaving 8 and 6, 21. And we read that 3 go into 21. It goes in 7 times. And we multiply 7 times 3. We write it here. We get 21. We subtract and we get 0. So our answer is 27, remainder 0. In this example, we see how many times does 4 go into 27? Well, 6 times. 6 times 4 is 24. Subtract it, leaving 3. How many times 4 go into 3? 0 times, so that's our remainder of 3, not 0. Right? You guys all remember how to divide? But what if we do that with variables? What if I told you to divide 2x to the 5th plus 5x cubed over x divided by x? Well, this is a really simple example. You don't even have to divide, right? You can just simplify. You can cross out the x, that becomes a 4, that becomes a squared, leaving 2x to the 4th plus 5x squared. You don't have to divide in some cases, but in some cases, the only thing you can do is divide. So instead of just simplifying, let's try to divide this example. We divide using the same setup, x divided by 2x to the 5th plus 5x cubed. So our first step here is the same as the first step of normal division. How many times does this go into this? Well, this is interesting, right? It goes in 2x to the 4th times. X goes in 2x to the 5th, 2x to the 4th times. So we don't write 2x to the 4th right above here because these are all in terms of exponents. So everything in the 5th exponent should be here. So we have to put this inside the 4th exponent column, which I should make space for. Plus 2, what is it? 5x cubed. So what we are supposed to do is, since it goes in 2x to the 4th times, we write 2x to the 4th here, and we multiply. 2x to the 4th times x is going to be 2x to the 5th, right? And we subtract. We subtract 2x to the 5th minus 2x to the 5th is just 0. 5x cubed minus 0 is left with 5x cubed. 5x cubed. X times, how many times does x go into 5x cubed? How many times do you guys think it will go in?
3.
3? 3, just 3? Like the number 3? Or in here, oh no. In here, x went to 2x to the 5th, 2x to the 4th times, because if we multiply here, we get the exact same number, right? That's what we want. So essentially, we're factoring, I guess. We factor x out of this. So 2x to the 5th, and we factor x out, leaving 2x to the 4th. So in this, it's the same. How many times does x go into 5x cubed times? What do you guys think? Well, it goes in 5x cubed over x is going to be 5x squared, right? So it goes in 5x squared times. And we write it in this column because this is a cubed column and this x squared column. It's going to be 1. These are going to be numbers and stuff. So 5x squared, we give 5x squared, and we do this thing. We multiply 5x squared times x, giving 5x cubed. And we subtract 1 then, 0. And there's nothing else to subtract. So we're left with 0. So that's our answer. We're left 2x to the 4th plus 5x squared. You see how these are the same? This is a lot longer, yes, but it is much more helpful, especially when we see remainders. So this is an example where the division, it came out really neat. The number was nice. We didn't have any remainders, but what if we do? Let's try another example with remainders. Let's try 5x squared plus x plus 6 divided by x. You see here, we can't divide x out because we can divide x out here like that and here, but there's no x there. So we can't really factor x. So what should we do? Well, we divide, leaving 5x squared plus x plus 6. So our first step is, how many times does x go into 5x squared? How many times do you think it goes in?
5x.
5x times, right? And where do we write 5x? Do we write it Can I write 5x there?
1 space to the right? Or...
Yeah, 1 space to the right. Because this is a separate column for just x's, right? So it goes 5x times, we multiply 5x times x, leaving 5x squared, and we subtract 0. And if we subtract 0, we're left with x and 6. 0 plus x plus 6. I guess I don't need to write 0. So how many times does x into x then? Just once, right? X times 1 is just x. So we write 1 here because this is the number column. Everything has its own group column, sort of. So we multiply 1 times x, it's going to be x. And we subtract once again. X minus x is going to be 0. And 6 minus 0 is going to be just 6. That's minus. So we're left with positive 6. But we can't ask ourselves, how many times does x go into 6? It doesn't make sense, right? So we're left with a remainder of 6. But in normal math, we just write our answer, 5x plus 1, and we write remainder 6, right? But in algebra, we don't do that. It's a form where our remainder goes over our divisor. And you add that to our answer. Let me rewrite that. If that's our answer, we add that to this equation. That's where r is the remainder. What's a divisor? Divisor is what we divide by. So in this case, x is our divisor. So what's our remainder? Remainder is 6, and our answer is 5x plus 1. So we add 6 over our divisor is x, 6 over x. So our answer becomes 5x plus 1 plus 6 over x. That's our answer. Not bad, right? Pretty simple. Let me just erase this. But in both of these examples, all we did was divide by x. What if we divide by something harder? Let's try dividing x squared minus 3x minus 10 divided by x minus 5. I guess you can factor. You can factor this to x minus 5 and x plus 2, right? X minus 5. These can cancel out, leaving x plus 2. But let's try dividing. Let's not do it the easy way. Let's try dividing. So if we divide x minus 5 and x squared minus 3x minus 10. So in here, you might be confused. Well, do we see how many times x minus 5 goes into x squared, right? This is a binomial and this is a monomial. So it's impossible. What you do is you only look at the highest term. X is our highest term. So we base everything off x. How many times does x go into x squared? Just x times. And the negative 5 just follows. Oh, my bad. X should be written here. And x times x minus 5, that's where it follows. X times x minus 5 is going to be x squared, and x times negative 5 is negative 5x. And we subtract. So we're left with 2x, and we bring the 10 down. So again, we ignore negative 5. We just look at the x. How many times is x into 2x? We ignore the smaller digit. Just 2 times, right? So 2 times x minus 5 is going to be 2x. 2 times negative 5 is negative 10. If we subtract, we're left with 0. Funny, we get x plus 2 here, and we get x plus 2 here. Do you guys get it? Pretty simple. Or should I explain it one more time?
One more time.
One more time. Okay, let's try a different example. Except let's try something with remainders. Let's try something with remainders. Okay. X squared minus 3x plus 9, x minus 2. That's our, if we rewrite this, we can rewrite this as x minus 2 divided by x squared minus 3x plus 9. Let's do this one together. So what's our first step, do you think? What are we trying to do?
Wait, what?
What do you think our first step to this problem is?
How many x can go into x squared?
Right. We ignore the smaller term. You're right. Okay. So how many times do you think x can go into x squared? How many times do you think that is?
X.
X times, right? And we write x here. And we just multiply. X times x minus 2 is going to be x squared. X times negative 2 is negative 2x. Yeah. Does everyone follow up till here? Everyone understands up to here?
Yeah.
Okay, let's move on. So we subtract. If we subtract, the negative 2x changes into a positive. And we subtract, leaving negative x. And we bring down positive 9. Okay, so we asked ourselves again, how many times does x go into negative x? How many times do you think?
Negative 1.
Negative 1, right. Negative 1. So we write negative 1 and we multiply again. Negative 1 times x minus 2 is going to be negative x. Negative 1 times negative 2 is positive 2. And we subtract. So these changes, what am I doing? If you subtract, this is going to be 7, right? But we can't ask ourselves again, how many times does x go into 7? Because 7 is smaller than x, right? So our remainder becomes 7. So what do you guys remember the equation? P of x, P of x plus remainder over divisor. So P of x is our answer. We got x minus 1. Our remainder is 7, so plus 7. And our divisor, what do you think our divisor is?
X minus 2.
X minus 2, you're right. X minus 2. And we're done dividing. Simple enough, right? Does everybody understand how to divide polynomials, I guess?
Yes.
Nice. Let's move on. I'm going to introduce something called the remainder theorem, which comes into play. So the remainder theorem is So if we have an equation p of x, let's say p of x is x to the 5th plus 2x cubed minus, I made this up by the way, plus 5x plus 1. Okay, let's say that is our equation, and we are told to divide this by x plus 3. Okay, we're told to divide this equation by this, and we want to know what the remainder is. Well, to find the remainder, it would take really long to go about this whole division process, right? It takes a long time. So we have this neat trick of finding the remainder without actually dividing. P of k is the remainder. So what is k? If we look at this binomial, our k is x minus k. This is our k. So we want to find k in our divisor, which is going to be -3. -3. And to find the remainder, we just plug it in this equation instead of the x's. So p of -3 is going to be -3 to the 5th plus 2 -3 to the 3rd, and so on. And you just plug it in and you get an answer, and that should be your remainder. Well, this is a pretty long equation, so it might actually take you a lot of time, but this can come pretty handy in some cases. Do you guys get what the remainder theorem is? Or should I explain it one more time? Nobody?
Can you explain it one more time, please?
One more time? Okay. Let's do a question actually. I'll explain it using a question. P of x is x to the 4th minus 2x cubed plus, let's say 4x squared plus 2. And our question is, what is the remainder when p of x is divided by x minus 2? So our question is, what is the remainder? Let's see. So in our divisor, we just want this number, which is 2. X minus k. In this form, we just want k. And in this case, k is going to be 2 because it's x minus 2. Knowing that k is 2, the remainder theorem shows us that p of k equals the remainder, p of k. So if we plug in k into an equation, we will get the remainder. So p of x is this long equation. So let's plug in 2. P of 2 is going to be 2 to the 4th minus 2 times 2 to the 3rd plus 4 and 2 squared plus 2. All we have to do is simplify. 2 to the 4th is 16 minus 2 times 2 to the 3rd is going to be -16. And 2 squared times 4 is going to be +16. Oh, that's weird. Plus 2, right? 16 minus 16 is 0, leaving us 18, which is our remainder. So our remainder is going to be 18. Does that make sense? to everyone?
I think so.
Yes.
Yeah.
Okay.
Yes.
Let's try. Let's try one more example where we kind of switch the example around. P of x is x cubed minus 3x plus k, k, where k is unknown, right? We don't know what k is. And P of x is divided by x plus 2, let's say. And when it is divided by x plus 2, we're left with a remainder of, we're given a remainder of 8. And we want to find k. What is k? That's a question. Well, in this case, we're given a remainder. We're not searching for the remainder. But we don't know what the equation is. But we do know that P of k is going to be the remainder. But let's do a different variable. Let's say a, because k is here. What do you think k is if we look at this binomial? What is k?
-2.
Right, -2, because our equation is x minus k. -2. So we know if we plug in -2, we are gonna get 8. So let's try that. P of -2. Okay, let's plug it in. -2 cubed, right? X cubed minus 3 times -2 plus, oh, we don't know what a is. Let's just write a here for now. And we know that is gonna equal 8. We're left with an equation. So all we have to do is solve for a. -2 cubed is going to be -8. Negative times -2 is +6. Let's leave the part of a here and 8. 8 is going to go to the other side and 6 can go to the other side, leaving a is equal to 10. Does that make sense? Where we use the remainder theorem, but in a different way to find something else. Hopefully that made sense too, yeah. We're gonna do one more example and call it a day. And this time we're going back to dividing. So we can also use division to find what our factors are. So P of x, for a given equation, x cubed plus 3x squared minus 4. And it's the P of x is this. P of x has a known factor, factor of x minus 1, let's say. And we want to rewrite P of x as a product of linear factors. Well, what the heck does this mean? Well, what does it mean to have a factor? We know that P of x has a known factor of x minus 1. So x minus 1 times something, let's say a, for example, is gonna equal this. That's what it means, right?
Yeah.
Something, and we want to rewrite P of x into this term, where we know what a is. So what do we do to find a? We just divide x minus 1, right?
Yeah.
Divide x minus 1. So this cancels out. So a equals this thing. And we're back to dividing. X cubed plus 3x squared minus 4 divided by x minus 1. How many times is x going to x cubed? Well, x squared.
Yeah.
And I'll do this quick since we're running out of time. X squared times x cubed. X squared minus 1 is negative x squared. We subtract, leaving 4. Wait, is it? Yeah, leaving 4x squared. We take down negative 4. How many times does, how many times does x go into 4x squared? Well, plus 4. Oh, I should have left a space here. So minus 4 is here. Plus 4x times 4x is going to be 4x squared minus 4x. Subtract, leaving. Oh, I rewrote this wrong. Our 4 should be here. That should be a 0. Okay. We subtract, leave negative 4x minus 4. Actually, positive 4x, since 0 minus negative 4x is positive 4x. And we do that one more time, leaving how many times x go into 4x? 4 times. We multiply. And just trust me on this, you're going to get a remainder of 0 when I multiply this. I don't have space, right? So that's our answer.
Yep.
And so we know that x minus 1 times this, x squared plus 4x plus 4 is the same as this, right? We're almost done. We can just factor this one more time. X minus 1. Let's factor this. If we factor that, I think we're left with x plus 2 squared. That's a special case of a factor. Does that make sense to everyone? How we can rewrite or factor polynomials using division?
Yeah.
Okay. Hopefully that made sense. I guess that's it for today. That's it for our lesson. Hopefully you guys learned a lot. I'll post the homework once again on Google Classroom. So good luck on that. But yeah, we're done for today.
감사합니다. Thank you.
Bye.
Thank you.
Yeah.
Thank you.
Thank you.
Thank you.